Welcome back, everyone. So now we're going to be talking about perimeter and area proofs. Once again, we're going to be using this distance formula pretty heavily because now instead of determining what kind of quadrilateral or what kind of shape it creates, these points create, what we're going to be looking for is what the perimeter of the shape is or what the area of the shape is. So for the first two examples, we're going to find perimeters, and the examples 3 and 4 we'll find areas. You have a key term sheet on this with all of the formulas for perimeters of triangles, perimeter and areas of triangles, perimeters and areas of quadrilaterals as well. So let's start with the first example. This first example has these 4 points, -4, 2, -1, 3, -4, 3, and -1, 2. The easiest thing to do, just so that you can visualize it a little bit, is to graph it first. If you don't like graphing beforehand, or if you don't feel like it's helpful, you definitely don't have to do it, but I think it's helpful. So -4, 2 would be like right there, -1, 3, like right there, -4, 3, and then -1, 2. So, okay, it's like a little rectangle, a baby rectangle. And let's see, I'm going to label them really fast. So this was A, B, B, C, and D, D. So what we're going to do, if I want to find the perimeter, I've got to find the length of all of these sides. So I'm going to start with from A to C, and then I'm also going to find B to D. Those are like my two short sides. Then I'm going to find B to C, and then I'm also going to find A to D. Those two, the bottom two, are like my long sides. And once I have all of those, to find the perimeter, I just add all of the sides up. So let's start with AC. We're going to do the distance formula, which we talked a lot about in the last video, but the distance formula is right up above on top of my screen. So when we plug AC in, I'm going to use C as the second point. So I'm going to have -4 for my x2 minus -4 for my x1 squared plus y2, so 3 minus 2 squared. When I plug that into a calculator, I should end up with 1. Then let's do from B to D. Now, if this is truly a rectangle, which it should be, the distances should be the same, but let's double check. So I'm going to use D as my second point here. So I'm going to have -1 minus -1 squared plus 2 minus 3 squared. Okay, plug it into your calculator. You get 1 again, so that's great. Then let's do from B to C. So these two are like my longer lengths. So I'm going to start C as my second point this time. So I'm going to have -4 minus -1 squared plus 3 minus 3 squared. If I plug that into a calculator, I get 3. Then let's do from A to D. Once again, we should get 3 again, but let's double check. I'm going to use D as my second point. So I'm going to do -1 minus -4 squared plus 2 minus 2 squared. All right, and I get 3. So good news, now we have all of the distances or the lengths of each side. When I want to find the perimeter of something, I just add all of the sides together. So my perimeter for this quadrilateral would be 1 plus 1 plus 3 plus 3, which is equal to 8. So my perimeter is 8. Okay, cool. Let's do the second example. So this time it's a triangle. Let's start by graphing it. Okay, so 2, 5 would be about there, and I'm going to label it A. Now let's do 10, 9. Which we'll label B. And then 6, 1, which we will label C. All right, so this is a triangle, a happy little triangle. And because it only has 3 lengths, we only have to find 3 distances. So I'm going to start by finding from A to B, and then we're going to do A to C, and also B to C. And then once again, kind of like what we just did with the last one, we find all of these distances, and then we add them all up to find the perimeter. So let's start with A to B. I'm going to use B as my second point, so I'm going to have 10 minus 2 squared plus 9 minus 5 squared, which when I plug it into a calculator, I get approximately 8.94. Okay, now let's do AC. I'm going to use C as my second point. So we're going to have 6 minus 2 squared plus 1 minus 5 squared, which gives me 5.66. I'm just rounding to the nearest hundredth on all of these because some of these numbers obviously are going to be a little bit gross because you're square rooting them. We could simplify the square root. On this one, I'm not going to make you do that though. So now let's do from B to C. C is my last point, or my second point. So I'm going to say 6 minus 10 squared plus 1 minus 9 squared, which gives me, let's see, $8.94 again. All right, so now to find the perimeter, we just add all of these sides up together. So we're going to say 8.94 plus 5.66 plus 8.94 again, which would give me 23.54, and that is my perimeter. Okay, awesome. So that's how we find perimeters. Now for the next 2 examples, we're going to find areas. So still the same setup. We're going to first graph these. So 5,1 would be about right here. I'm going to label it A. Then 5,10, we're going to call B. And then 1,1, we're going to call C. So this, and the triangles that I'm asking you to find the areas of will always be right triangles. That way you don't have to do anything but find the distances. So to find the area of a triangle, we have to say the formula is area is equal to 1/2 base times height. So we want to find the base length and the height length. You don't have to find the other length. So we only need to find 2 lengths in this case. The base length will be from A to C because that's like your bottom. And then your height length will be from A to B because that's your height, or the kind of like from the lowest point to the highest point. And then once we find the base and the height, you don't need to find from B to C. That doesn't matter for the area. But once we find the base and the height, then we can plug it into my area formula. So I'm going to start with AC, which we'll use C as my second point. So we're going to do 1 minus 5 squared plus 1 minus 1 squared, which gives me 4. Then let's do from A to B. I'm going to use B as my second point, so I'm going to say 5 minus 5 squared plus 10 minus 1 squared, which gives me 9. And I think I set all of these up so that they're really, particularly for the area ones, so that they're really pretty numbers. So you shouldn't have too much trouble with these. So now this is my, from A to C was my base, so that's our base. And then from A to B was our height. So when I plug this into my area formula, I'm going to say area is equal to 1/2 times my base, which is 4, times my height, which is 9. And then I plug that into my calculator, and I end up with the area as 18. There we go. All right, let's do this last example. And the last example is another area one. So first things first, let's graph it. So -10, 2, 2, 4. We'll call that A. Negative 8, 3. I'm going to call that B. Negative 9, 2. Ooh, this is going to be a little one. And then negative 8, 1. Whoa, what did I do? Let's see. Negative 8, 1. Did I graph that weird? Negative 10, 2. Oh, you know what? I did. I'm going to switch this. So, all right, so this is going to be our D. Let me do some erasing really fast. We're going to erase our A. And instead, we're going to make this our D. And instead of negative 10, 2, I want it to be right here. So I want it to be negative 7, 2. And I changed that on your examples already. So ignore like the last 20 seconds of this video. And this is A. So just so that you can kind of see it a little bit better, this is kind of what it looks like where we have C, D, B, and A. All right, so if I want to find the area of this sucker, first of all, this is, it's like a square, it's a square, but it's tilted on its side. And so we can use, to find the area of a quadrilateral or a four-sided figure, you can say the area is just base times height. But the other thing that you can do when it's tilted on its side like this, the other area formula is area is equal to 1/2 diagonal 1 times diagonal 2. So what I'm going to do is find the diagonals, which are from A to C and B to D, and then I'm going to use this formula to find the area. So I'm going to start by finding from A to C, then I'm going to find from B to D the distances, then we can just plug it straight into the formula. So A to C would give me, use the C as the second point, so we're going to have negative 9 minus negative 7 squared plus 2 minus 2 squared, and we end up with 2 as our distance. And then B to D, we're going to have, I'm going to use D as my second point, so I'm going to have negative 8 minus negative 8 squared plus 1 minus 3 squared, which again gives me 2. So when I plug it into the formula, I'm going to have 1/2, area is equal to 1/2, 2 for diagonal 1 times 2 for diagonal 2, which gives me 2. So my area is 2. All right, and there we have it. This is how we find the perimeter and area based on coordinate points.